All right, so I'm super happy to be here at RubyConf to talk about Roda. So Roda is a web toolkit that I launched in 2014. I had the pleasure of presenting the newly launched Roda at RubyConf 2014, and it's great to be back at RubyConf 10 years later to discuss Roda's progress. So in this presentation, I'll be going over the advantages of using Roda, discussing the progress made in the last 10 years since launch, and looking at how some open source software uses Roda. My name is Jeremy Evans. I maintain Roda and many other Ruby gems. I'm also a Ruby committer who focuses on fixing bugs in Ruby. Additionally, I'm the author of Polished Ruby Programming, a book aimed at intermediate Ruby programmers. So before discussing the first 10 years of Roda, I'm going to dive right into a simple Roda example, in case you are not familiar with it. And while a little bit more complex than Hello World, this example shows Roda's key advantage over other Ruby web frameworks, which is the ability to handle requests during routing instead of separating the routing process from the request handling process. So with Roda, all requests to the application are yielded to the route block, and the route block is responsible for handling all requests. By convention, Roda uses R as the route block variable. At any point in the route block, you can do processing related to the request. For example, if you want to check access by IP, you could have that check at the top of the route block. And this would be the equivalent of an application level before hook in other frameworks. Now, assuming we pass the access check, we get to the first routing method. So the r.on method is used to handle branches in the routing tree. In this example, the r.on method is passed two arguments called matchers. And the first is the string employee, which will match if the next segment in the request path is employee. And the second is the class integer, which will match if the next segment in the remaining path is an integer. So if you look at the combination of these two matchers, they will match a request path such as /employee/7. And since the entire request path has been consumed by the matchers, the remaining path is empty. The matchers will also match a request such as /employee/7/name. And the remaining path after this would be /name, which is what routing methods inside the block would operate on. It would not match a path such as /vendor/9, since the first segment is not employee. And it would also not match a path such as /employee/name, because name is not an integer. Now, if the request does not match the r.on call, r.on will return nil without yielding to the block. And in this example, it would reach the end of the route block, resulting in a 404 response because the request was never handled. If the request does match the r.on call, it will yield to the provided block. And because the integer class matcher was used, the block would be yielded that segment of the request path converted to an integer. So for a GET request for /employee/7/name, the employee ID block variable would be the integer 7. Now inside the block, the first line is this code, which shows the primary advantage of Roda, which is at any point during routing, you can do processing related to the request. Now in this case, we're using that employee ID block variable to look up the employee by ID and then setting the employee variable. All routes under this block can then access the employee. Now you can get similar behavior in other frameworks using before hooks, but this provides a simpler approach that avoids indirection. If you've ever had to debug issues in your applications involving the use of before hooks, I think you can appreciate this approach. Now, what if there is no matching employee for the ID? Well, in that case, you can use the next keyword to return nil from the block, which Roda will treat as a 404 response. Now, this ensures there is a valid employee for the rest of the block. So the next routing method is r.is with a string name matcher. Now, r.is is similar to r.on, except that it requires that the request path has been fully consumed after all the matchers have been applied. So for our request, since the employee and 7 segments have already been consumed, the remaining path is /name, and the string name matcher will match that segment. And since the entire request path has now been consumed by the matchers given to the routing methods, the r.is method will match and it will yield to the block. Now inside the r.is block, the first method call is r.get, which will match because the request being handled uses the get request method. Now the r.get block returns a string hello followed by the employee's name. And as the block returns a string, This string will be used as the response body. So let's see how a post request to the same path will be handled. So the path of the request will still be fully consumed by the matchers given to the r.on and r.is methods. However, the r.get method call will not match, as this is a post request and not a get request. So r.get will return nil without yielding to the block. And the next method in the block is r.post, which will match because this request is a post request. So r.post will yield to the block. Now in this case, we will use the name parameter to update the employee's name, and then we will redirect the request. And since no arguments are given, this will redirect to the same path, but using a get request and not a post request. So hopefully this example was able to give you a basic idea for how Roda's routing tree works. The most important part to remember is that Roda gives you the power to do processing related to the request at any point during the routing process. This reduces duplication and indirection and results in applications that are simpler and easier to understand. Simplicity is one of Roda's 4 goals. After 10 years developing Roda, I still think that the primary benefit of Roda is it allows the same application to be built more simply than in other frameworks. Another of Roda's goals is performance. And unlike the simplicity goal, where the benefits are subjective, you can see objective differences between the performance of Roda and other web frameworks. We're going to look at 2 benchmarks. The first is R10K, which is a synthetic benchmark that measures per request overhead and scalability for large numbers of routes. Now, R10K benchmarks applications with 10, 100, 1,000, and 10,000 routes. And to avoid web server overhead, it benchmarks using the Rack API directly. So here are the request per second results for Roda, Rails, Sinatra, Hanami, and Camping. And it shows Roda is much faster than other frameworks. Now, unfortunately, the scale of the graph makes it difficult to see how the other frameworks compare. So here's the same graph, but using a logarithmic scale. And this still shows Roda is much faster, but it also shows that Roda, Rails, and Hanami all scale well for large numbers of routes. It shows that Sinatra and Camping do not scale well for large numbers of routes, and that's because both use a linear search of routes during request handling. Now, R10K also provides memory benchmarks, and these show that Roda uses less memory than other frameworks. Rails uses about 3 to 4 times more memory than Roda in this benchmark. And while the R10K benchmarks are useful, they don't tell you much about the real-world performance differences. So for that, the Tech and Power web framework benchmarks do a better job. Tech and Power has been benchmarking web frameworks in many languages for over 10 years, and Roda has led the Ruby web framework benchmarks ever since it was added in 2017. So here are the composite score results for the most recent round of Tech and Power benchmarks for Ruby web frameworks. And Roda leads in every category. The weighted score for Roda is about twice what the rated score is for Rails, and that lines up with results I've seen from applications converted from Rails to Roda, where the converted Roda application is about twice as fast. As the benchmarks show, Roda achieves its performance goals. It's the fastest Ruby web framework, scales well, and it uses the least memory. It's the fastest framework largely because it has the lowest per request overhead. Roda is designed to minimize the amount of work between when it receives the rack request environment and when it starts processing the routing tree. Roda scales well because it uses a routing tree. As soon as a branch of the routing tree is taken, other branches at the same level are no longer considered. And finally, Roda uses the least amount of memory because it is designed around a small core. And that small core handles basic routing and request handling. All other features are added via plugins. Roda's core is itself a plugin, and plugins can override any part of core Roda and any previously loaded plugins. As an example of its minimalism, Roda's core does not include template rendering. Template rendering is supported via a plugin. And it's common to use this plugin if you're writing applications that are targeting browsers. However, if you're designing an application that just serves API responses via JSON, you wouldn't need it. In that case, you'd probably want to use the JSON plugin, which allows route blocks to return arrays or hashes and have those converted automatically to JSON and used as response bodies. The reason I refer to Roda as a toolkit is you can think of each plugin as a tool, and different applications require different tools. And with Roda, you only pay the overhead cost for the tools that you choose to use. Roda ships with over 120 plugins to handle the needs of a wide variety of web applications, and there are numerous external Roda plugins to handle additional needs. So this approach of having a small core and shipping all optional features as plugins is how Roda achieves its goal of extensibility. Roda's final goal is reliability, and Roda achieves this goal by combining two development approaches. The first is immutability. So Roda applications are designed to be frozen in production and when testing, and this reduces the possibility for thread safety issues, as well as memory leaks due to unexpected object retention. Now, immutability is not just for reliability in Roda either. In Roda, immutability also improves performance. When you freeze your Roda application, Roda knows there'll be no further configuration changes to it. Roda then determines whether the methods that it offers that are designed for extensibility have not been overridden. And in that case, it overrides the default extensible methods with optimized methods. And that gives you the best of both worlds: extensibility when you need it, and maximum performance when you don't. The second development approach related to reliability I refer to as pollution control. More explicitly, namespace pollution control. Roda limits the pollution of your constant, method, and instance variable namespaces in your application. All of the internal constants in Roda are prefixed with Roda, so to avoid conflicting with user-defined constants. Roda limits instance variable pollution by prefixing all internal instance variables in route block scope with an underscore. If you've ever developed a Sinatra application and tried to use request or response instance variables, you will appreciate this. Roda limits method pollution by only defining 6 methods in Roda block scope, beyond the methods that are defined in object and some private methods that begin with an underscore. And this makes it less likely that a user-defined method will conflict with a Roda method. So now that I've given you a brief taste of Roda and discussed how Roda has achieved its goals, I can start discussing the first 10 years of Roda. Now, Roda's first release was on July 30th, 2014, and its most recent release, the 125th release, was 3 days ago. Now, I don't like waiting long to use new features, so Roda follows a simple-to-understand release schedule. There's a new Roda release every month, around the middle of the month, ever since 2014. I also don't like it when changes to a library break my applications, so Roda places a high priority on backwards compatibility. I think the compatibility is so good that the majority of applications that worked with the first release, Roda 0.9, would still work if you upgraded them to the latest release, Roda 3.86, with one main exception. If we go back to our first example, we see that it uses the integer class matcher. However, Roda did not support using the integer class as a matcher until Roda 2.27. Before Roda 2.27, this type of matcher would generally be written using what is referred to as a placeholder string, with placeholders in the string being prefixed by a colon. Now, this style resulted in 2 issues. First, it resulted in redundancy. Most developers would name the placeholders similar to the block variables. And that's not technically a problem, but it is a tad annoying. The actual problem was a performance problem, which is that you needed to scan all strings that are used as matchers to see if the strings contained placeholders, and then treat the string differently if it had a placeholder. Strings are the most common type of matcher, so this check resulted in a measurable slowdown even if you were not using placeholders. So Roda 3 removed support for placeholders in string matchers by default, and in order to support backwards compatibility, Roda 3 shipped with a placeholder string matchers plugin. Now, I analyzed a couple of my open source applications, checking out the commit where the application was converted from Sinatra or Rails to Roda 0.9 and trying it with the current version of Roda. And in both cases, adding the placeholder string matchers plugin was the only Roda-related change necessary to get the specs passing with the current version of Roda. I mentioned that one of the reasons for breaking backwards compatibility was to improve performance. So how much did this change and other changes improve Roda's performance over the last 10 years? To determine that, we're going to look at some more R10K benchmarks to see how Roda's performance has improved over time. Additionally, as Roda is a fork of another web framework named Cuba, we're also going to compare Roda to Cuba. So let's start with Roda's initial release, compared against the current Cuba release at the time. As you can see, performance is basically the same. For the initial release, I was focused on differences in route block handling block responses, and getting the plugin system working. I wasn't focused on performance, since Cuba was already much faster than other Ruby web frameworks at the time. Less than a month after the initial release, I released Roda 1.0, and this had a massive boost in performance over the initial release with a number of additional optimizations. At the time, most of the matchers in Roda were based on regular expression scanning, and the most important optimization was the caching of regular expressions instead of generating a new regular expression for every matcher. About 6 months after releasing Roda 1.0, I released Roda 2.0, which improved performance over 1.0 by about 20%. Now, this performance improvement was due to reducing allocations during matching so that each match attempt did not modify the request environment. About 2.5 years after that, I released Roda 3.0, which improved performance over 2.0 by about 40%. So this performance improvement was mostly due to avoiding regular expressions during matching and the removal of placeholders during string matching. Instead of regular expressions, string methods such as start with and index are used, and this idea was taken from Cyro, a routing library by the same author as Cuba. By January 2021, with the release of Roda 3.40, performance had increased another 15%. This performance increase was due to a couple of optimizations. During this time period is when I added the optimization during application freezing. Additionally, the performance of string and segment matchers was improved about 15%, and terminal matching by about 400%. Between Roda 3.40 and 3.60, performance increased another 30%, and this was due to additional optimizations on the most common matchers. Roda's current performance is about the same as Roda 3.60. So between Roda's initial release and the current release, performance in this benchmark improved by a factor of 12. And I think that's pretty amazing considering that even at Roda's initial release, it was one of the fastest frameworks. However, this is not the limits of Roda's performance. Using the optimized string matchers, optimized segment matchers, and plain hash response headers plugins, performance can be increased another 35%. And this does require some small sacrifices in usability, though. Now, R10K is a routing and per request overhead benchmark, and Roda has improved greatly over the years at that. However, that's not the only way that Roda has improved performance. Many of the plugins that ship with Roda have been optimized as well. For example, the render plugin has shipped with every release of Roda, but it and related plugins were extensively optimized a few years ago. For simple templates, the render plugin is about 4 times faster than it was originally. Speaking of plugins, Roda 0.9 shipped with 15 plugins, and Roda 3.86 ships with over 120 plugins, more than 8 times as many as the initial release. So I'm going to take you on a quick tour of the last 10 years of Roda plugins. In the initial release, in addition to rendering, Roda shipped with plugins for handling exceptions, customizing default headers and 404 responses, handling flash messages, streaming responses, and operating as rack middleware. However, one of the most important plugins was the ability to use separate route blocks. If you remember back to our original example, I mentioned that all requests are yielded to the route block, and the route block determines the response. Now, in Ruby, you could not split a block across multiple files, and having all routes in a single file only makes sense for small applications. To handle large applications, you need a way to separate the route block. And even the very first release of Roda supported that via the multi-route plugin. So with the multi-route plugin, you could call r.multiroute in your main routing block, and it would dispatch to separate routing blocks based on the next segment in the remaining path. Those routing blocks would generally be stored in separate files based on the route segment name, like this. And that made it simple to organize large applications in Roda, and allowed even the first release of Roda to scale from simple single-file applications to decent-sized applications. Roda 1.0 added 11 new plugins not in the initial release, and these included plugins for returning arrays and hashes as JSON, cross-site request forgery protection, rendering a collection of partials in one call, and having a separate view subdirectory for separate branches in the routing tree. Additionally, the render plugin was expanded to support the automatic escaping of output in templates, greatly reducing the likelihood for cross-site scripting issues. I think my favorite plugin addition in 1.0 is symbol views. So the symbol views plugin is very simple, but it allows you to replace manual calls to view to render templates and just have the route block return a symbol. And this small change dries up a lot of route code and makes the common case of rendering a template inside a layout even simpler than it is in Sinatra or Rails. Now, not everyone is a fan of this terse style. However, just because I think a particular style is nicer does not mean I think I should force it on all Roda users. Between Roda 1.1 and 1.3, 25 more plugins were added, including plugins for managing HTTP caching, incrementally rendering templates, and compiling, compressing, and serving asset files. Roda 1.2 added the mailer plugin, which brought the benefit of routing trees to sending emails from applications. So here's an example that uses the mailer plugin. Generally, you use the mailer plugin in a Roda subclass designed specifically for sending emails. Unlike a Roda web application, which is designed to handle HTTP requests, a Roda mail application is designed to handle internal requests. However, sending mail with the mailer plugin is done by providing a path, just like with an HTTP request. A Roda mail application uses the same basic routing methods that a Roda web application uses. And just like in a Roda web application, at any point when handling a mail request, the Roda mail application can do processing related to the mail. So here we're setting the sender and recipient addresses, so those don't need to be duplicated inside every mail handling block. Now, the r.mail method is used to handle mail routes, and it operates similarly to r.get and r.post. In this case, the time-off matcher matches the remaining path, so the method will yield to the block. And the block sets the subject for the mail and returns the symbol for the mail template to render. And returning a symbol works here because this mail application also uses the symbol views plugin. Now, between Roda 2.0 and 2.29, 22 more plugins were added. These included support for sending preload headers for assets, serving public files at specific places in the routing tree, rewriting paths prior to routing, parsing JSON request bodies to parameters, fast O1 routing to static paths, and having the routing tree support file extensions in the request path specially. Roda 2.27 added the class matchers plugin, which allows you to specify the handling of arbitrary classes that are used as matchers. Going back to our initial example, we see that we are using the integer matcher, which yields an integer. We're then looking up the employee using the integer and have to manually handle the case where that lookup fails. Using the class matchers plugin, we can simplify this. We can register the employee class as a matcher and build on top of the integer matcher. If there's a match by the integer matcher, the value is yielded to the block as an integer, and the block can then do the employee lookup. And that allows the routing tree to be simpler. Every case where you're trying to match an employee, you can pass the employee class as a matcher, and it will yield the employee object to the routing block if the segment was for a valid employee. And if the segment was not for a valid employee, it just wouldn't match. Between Roda 3.0 and 3.29, 12 more plugins were added, including support for encrypted sessions, early hints, content security policies, processing incoming emails using a routing tree, logging in common log format, showing nice exception handling pages in development, splitting the routing tree into subtrees without using regular expressions, and supporting stronger cross-site request forgery protection with tokens specific to the request method and path. Roda 3.3 added a typecast params plugin for handling the typecasting of submitted parameters to expected types. So here's an example of use, showing automatic conversion of a given parameter to a positive integer, ensuring that attackers cannot try to submit an array or a hash. Now, typecast params has support for nested parameters, typecasting arrays of values to expected types, and custom parameter types. It's designed to be simple and not verbose. Between Roda 3.30 and 3.59, 17 more plugins were added, and these included support for host authorization, trying multiple render engines and multiple view directories when rendering templates, using arbitrary objects as matchers during routing, supporting multiple directories for public file serving at different places in the routing tree, and a simpler approach to dispatching to separate routing trees, which can automatically set the view subdirectory during the dispatch. Now, between Roda 3.60 and the current version, 3.86, 19 more plugins were added, and these plugins included support for handling arbitrary objects returned from routing blocks, auto-loading hash branches for faster development and testing, setting a permissions policy, enforcing cookie flags, handling invalid request bodies, and measuring line and branch coverage of templates even in Ruby versions that do not support coverage for evalid code. Roda 3.79 added an HMAC paths plugin, which allows you to easily prevent path enumeration by including an HMAC in the path. So going back to our initial example, we see that this allows anyone to issue requests for this branch. What if you want to prevent someone with access to the application from enumerating the employees? Well, using the HMAC paths plugin, we can wrap the routing block in r.hmac path, and when generating paths in your application, you would call HMAC path with the path, which would prefix an HMAC and some metadata, such that r.hmac would consider it valid. And the HMAC paths plugin was expanded in Roda 3.80 to support session-specific HMACs, so that paths valid for one logged-in user would not be valid for a different logged-in user. It was expanded again in Roda 3.81 to support paths that are only valid for a limited time. So that's a brief tour of plugins that Roda has added in the first 10 years. I'm going to finish up this presentation by discussing two open source applications that are built on top of Roda and how they are using Roda's features. The first application is Karafka Web, which is a web front end for Karafka, a Ruby gem for working with Kafka, which is a distributed publish-subscribe queue. Now, Karafka Web ships all of its asset files inside the gem, and it uses Roda's public plugin, and it serves the assets using a path based on the gem version. And this automatically handles cache invalidation by using a new path for each gem version. Karafka Web uses the custom block results plugin so that route blocks can return Karafka Web specific objects, which are translated into HTTP responses. And this reduces duplication inside the routing blocks. Now, the second application is RubyCloud. RubyCloud is an open source alternative to Amazon Web Services. It's being developed by a startup also called RubyCloud. Now, RubyCloud uses the Roda authentication framework to handle authentication. Roda is Ruby's most advanced authentication framework with built-in support for multi-factor authentication such as TOTP and WebAuthn. Now, Roda is a Roda plugin, but you can use Roda even in non-Roda applications by using Roda's middleware plugin and using the Roda application as middleware. Now, RubyCloud uses multiple Roda configurations because it uses Roda to handle authentication both for browser logins as well as for its JSON API. So this is the section of RubyCloud's main route block, which is designed to handle browser requests and GitHub webhooks. Now, RubyCloud is a decent-sized application, so it uses the hash branches plugin to separate the routing trees. It actually has two separate dispatches to routing trees here. This one is for the main application, and it's used for logged-in users. Webhooks dispatch to a different set of routing trees, as they don't need cross-site request forgery checks, nor do they require the same authentication as logged-in users. And this type of setup is possible in other frameworks, but it is significantly simpler in Roda. So that's how some production open source applications are using Roda to simplify their web development. And as we get near the end of this presentation, I'm happy to announce that after 10 years, Roda recently passed 10 million downloads. So if you haven't already tried using Roda, now is a great time to start. If you're wondering about the future of Roda, I'm happy to announce that I've joined RubyCloud, and part of my job is continuing to maintain Roda and other open source libraries on top of which RubyCloud is built. I hope you had fun learning about the first 10 years of Roda. If you're looking to reducing your cloud spend, or you want an easy way to deploy Ruby apps to the cloud with Kamal, stop by the RubyCloud booth and talk to us. We would love to work with you on it. And that concludes my presentation. I'd like to thank all of you for listening to me. I have maybe a minute for questions. Yeah, is there an instance where you wouldn't want to use Roda? Well, it depends on what you're doing. Obviously, like compared to Rails, if you're dealing with a lot of people that already know Rails, or you're using libraries that work with Rails, you'd have to find equivalents to Roda. Now, I think for a lot of the major stuff, that's probably possible, but you might have 3 or 4 options in Rails and only 1 in Roda. For more niche cases, you might have options in Rails and not have options in Roda. So a lot of it depends on what you're doing and how much code you want to reuse out there. And whether or not there's alternatives that you can use it in Roda. So it also depends on how familiar the team is with Rails versus with Roda.